Do you know how to detect actual support in CSS? Do you know how to increase the clickable or tappable area of your buttons without affecting layout? And most importantly, did you know that you can recreate entire x86 architecture in pure CSS? Find out all about this and more in the next few minutes. This episode is sponsored by DebugBear. More on how you can improve your website performance in a bit. First up, Bramus van Dam explains how to detect actual support in CSS with supports actual. When you're working with CSS features that are not in the baseline yet, you need to ensure that everything works fine in browsers that don't support those features. And this is exactly where supports actual comes in. You're familiar with it. You can use it to test if the browser supports a certain CSS feature and then run a block of CSS only if it does. The problem with supports actual is that you couldn't actually test if a browser supports a certain actual, or specifically this was impossible until now. Starting with Chrome 146, you can do this, and this is exactly how. You need to use actual keyword, and then in the parentheses, you're gonna enter the rule that you want to test. This will also work in your import statements, but the thing to note is that it doesn't work with descriptors, preludes, or full blocks. So you can't do something like this. As I mentioned, this is supported in Chrome 148 and up. There is no support in Firefox or Safari yet. Hopefully the support will come soon, but you can play with it today in Chrome Canary, or if you enable experimental web platform features flag in Chrome Stable. At the time of recording, this is Chrome 146. As you can clearly see here, this is already working for me because I am using Chrome 146 with experimental web platform features flag enabled. This week's sponsor is DebugBear. If you want to make your websites faster, if you want to monitor performance on your websites, apps, and projects, then you have to use DebugBear. It provides in-depth web performance analytics based on synthetic tests and real user monitoring. With DebugBear, you will be able to easily detect critical issues on your website and identify potential solutions, along with measuring how performance impacts conversion rates. Hit the link in the description and start monitoring web performance with DebugBear today. You will definitely be happy that you did so. Thanks so much to DebugBear for sponsoring. Next up, Robin Rendell explains a problem that you've probably seen a number of times. If you have an icon like this one, you actually want to have a bigger click area than the icon itself. So you want to expand this element, but not visually. You just want to give users a bigger space for their interaction, be it a click or a tap. I've done this a number of times on my menus where I don't have like a containers, but just pure text. I want the clickable area to be bigger than the actual text. To accomplish this, you can add padding around the element, but this affects the layout, so it's not really ideal. Or you can go a different route and create a before element. Maybe you can position it absolutely, so you just give users a bigger area to click. Well, there's a new proposal that will fix this problem, and that proposal is pointer box offset. This property would allow you to extend the interactive area of an element without actually affecting layout or without doing anything special like adding additional pseudo elements behind the element. This proposal was created by Tyler Sticka. You can find it on GitHub. If you want to read through, this is a really interesting discussion about increasing the pointer target size independently of element layout. I would really love to see this in browsers because I think it's a really good enhancement and it fixes a problem that I personally had a number of times, and hopefully we will get another CSS property that will help us avoid this problem entirely. Next up, Daniel Schwartz shows different ways to select HTML and CSS. And this is a really interesting article that I definitely think you should check out. If you want to target an HTML element in CSS, there are actually quite a few ways you can accomplish that. The obvious one is, of course, HTML tag. You've done this countless times. Then you have a root pseudo class, which does exactly the same thing in HTML documents. It will target the HTML element. And I'm sure you're using this to actually set your CSS variables or CSS custom properties. But there are also other use cases when this is really helpful, specifically in SVG, RSS, ATOM, MATML, and other XML documents. The root will match the top element of that document. For SVG, this is going to be SVG. For RSS, it's going to be RSS, and so on. That is actually the main advantage of using the root instead of HTML. But there are also other pretty hacky ways that you can utilize target HTML. Another example is using scope or and is typically used for nesting in CSS, but if you add it at the top of the element, this is going to actually target an HTML element. Then you have another cool example. You can target all elements on the page that have head, or alternatively that have body, and this is only going to target an HTML element because there are no other elements in HTML where it's valid to have head or body elements as children. Then another cool example is not star star, or essentially the only element in HTML that does not contain other elements, that doesn't have any children, is HTML element. The things we've shown here are probably not that useful and practical, but you might happen to stumble upon a case where you need to find a creative solution to a certain problem, and then you will think of something like this, which will help you solve the problem you're having. In any case, a really interesting read by Daniel Schwartz. Next up, we have a really handy command line utility called Mole. It will help you deep clean your Mac and optimize it all from your terminal. It is packed with features. It will analyze your Mac in depth and clean it up properly. You can install it via Homebrew or directly with a script. And once you do, you can run it from your command line as in mo clean, and you'll find all the available commands right here in the docs. And to show you how great it actually is, I will run it from my terminal. I will use the mo-purge command, which cleans project build artifacts. This will essentially clean up the code folder on my Mac. Let's try it. Mo-purge. Depending on the amount of garbage you have on your system, this can take a while, but once it finishes, you will get a nice list of everything that can be cleaned up. On my system, the biggest offenders currently are Next and Node modules folders. Exactly as you would probably expect. I want to remove all of those, so I'm just going to hit enter here, and this will actually remove 3.2 gigabytes of data. Just to give you an idea about how useful this utility really is, I've cleaned up my system about a week ago, and it cleaned up about 30 gigs of Node modules folders. So what you're seeing here, this 3 gigs of Node modules and Next files, this is just in the last week as I've been developing on my system. Pretty wild stuff. Of course, this is just the tip of the iceberg. You're going to find more useful commands here that you can utilize to clean up your Mac properly. Last up, we have an absolutely amazing demo created in pure CSS, x86 CPU made entirely in CSS. Yes, this is the computer architecture that was created just in CSS by Lyra Rebane. If you want to understand exactly how this works and why it works at all, you're going to have to wait for a blog article that seems to be in the works. I really hope that we will be able to read really soon, and I will definitely share it in CSS Weekly. So subscribe to CSS Weekly YouTube channel and to the newsletter so you don't miss it. But in the meantime, I'll just mention that this project implements most of the x86 architecture. Well, apparently there's some behavior that is wrong and some things are missing, but you can actually write your own programs and execute them on this architecture that is created in pure CSS, and it will actually work. This is absolutely amazing. If anybody is still questioning whether CSS is a programming language and the if statements are not enough to prove otherwise, then, well, perhaps you have to send them this demo, x86 CPU architecture made in pure CSS. Absolutely amazing work by Lyra Rebane. Thank you so much for your attention, and thanks so much to DebugBear for sponsoring. My name is Zoran Jambor. I will see and hear you in a different CSS x86 architecture demo, or rather, in the next video.